So the next section that we're going to talk about is section 6.4, and this is solving logarithmic equations. So how are we going to do this? Well, actually, the technique is almost exactly the same. There's a lot of translation, but instead of from exponential to log form, we're going to translate from log form to exponential form. So we're going to talk about some basics here. Let's just dive right into some examples. Our first example, example number 1, solve for x. Log base 5 of 18 minus x squared is equal to log base 5 of 6 minus x. Now, in order for this to work out, I guess the first thing that we should talk about, important. These logs must have the same base to proceed with the problem. If they do not, we must rewrite the logs so they do have the same base. Now, in this particular case, we have the same base. So we can proceed. Now, there's a couple of different ways that we can go here. What the book, I think, wants you to do here at first is to use the property of one-to-one functions. So, option 1. Again, there's a lot of different options here, and I don't want to pigeonhole you guys and force you to do it one particular way. So, options 1. Since log functions are one-to-one, then equal outputs have equal inputs. So if log base 5 of 18 minus x squared is equal to log base 5 of 6 minus x, then 18 minus x squared must equal 6 minus x. If the outputs are equal, then the inputs must be equal. So that's pretty straightforward. That's a property of one-to-one functions. Here, if we bring everything over to one side, we're going to get x squared minus x minus 12. And this is now quadratic. And this one actually factors. This is x minus 4 times x plus 3, in which case x is equal to 4, or x is equal to negative 3. Now, a word of warning. Our original equation was a log equation, but we solved a corresponding quadratic. Now, we must check to see if both answers are correct. And the reason being here is this. A quadratic like we have here, x equals 4 and x equals -3, both perfectly viable solutions. But suppose we take x equals 4 or x equals -3, plug them back in for x, and we end up with log base 5 of a negative number. That would be undefined, and that would be what's called an extraneous or erroneous solution. So we need to be careful and make sure, that is, i.e., are x equals 4 and -3 in the domain of each log. Well, let's double check here. Log base 5 of 18 minus 4 squared is log base 5 of 2, which is defined. Log base 5 of 18 minus -3 squared is log base 5 of 9, which is defined. And log base 5 of 6 minus 4 is also log base 5 of 2. And log base 5 of 6 minus -3 is log base 5 of 9. Check. Everybody's defined there. And so we can see, in fact, these two are equal, as are those two. So we're also checking the equation and making sure that both of our answers are correct. So here, both values are correct. So we got lucky on our first example. Okay.